So we are in a good place. We're going to start with more graphing of rational functions. All right. So first thing I want to do is figure out if I have a horizontal asymptote. If I look, leading x terms up here are x squared and x squared. These are the same. So all I need to do is simplify, and that just simplifies to 1. So y equals 1. All right. Vertical asymptotes come from the denominator, so I want to make sure that nothing cancels out here. So I'm going to figure this out. So anything, if anything that cancels, I have a hole. I have a hole. And there's a special way that we figure out where that hole is at, but we can also use the graph of this function. But let's factor first. So I need two numbers that multiply to, this is a quadratic, they multiply to -6, multiply to -6, and add up to 1. So factors I have of 6 would be 1, 2, 3, and 6. So 1 and 6 give me 5 or 7. 2 and 3 give me 1 or -1. I have a -1 here. It's a -1. So I'm going to have a -3 and a +2. On the bottom, it's just the difference of two squares. So square root of x is x, and square root of 9 is 3. So x plus 3 times x minus 3. And right here, I can see that this cancels. So I'm going to have a hole at 3. So I need to figure out what my y value is. So I'm going to put a y question mark, all right? But I'm going to have a vertical asymptote in what is left over, and this is the way it works. X plus 3 equals 0, so x equals -3. So when I go graph this equation, which I'm going to do in a second, I'm going to figure out, this is x equals -3, that's my vertical asymptote. I'm going to make my other asymptote at y equals 1. Okay, and so because right now we're experimenting, we're going to go focus on this hole. I'm going to put a little notation here, hole. All right. Now the height of this hole. Let's go see what it is. So I'm going to go graph this equation here. And I'm going to go to where x equals 3. I'm going to go feature it right here. And I'm going to go ahead and use the graph to get this information. So I have x squared minus x minus 6. Okay, that's 1. On the bottom, I have -9, vertical asymptote of -3, horizontal asymptote of, looks like 1. And then I'm going to go look at this graph and look at that hole, the height of that hole. And I'm imagining at 3, it's going to be 5/6. And how do I get that? Let's turn this off for a second so I can see where this is at. And I'm going to look, actually, let me see what 5/6 is. I'm going to tell you how I got that. It's 0.833. So as you can see, it's undefined on the graph. There's a hole there. So what I'm going to do, I'm going to show you how I would do it on Desmos. I get 3 and 5/6. And I'll tell you how I got this in just a second. Let me change that to a hole. All right, let's make it black. All right, So that is what the sketch looks like. I feel like something's wrong here. Yeah, that needs to go. All right, there we go. Everything is there. I can turn that back on. And I'm actually not going to use this sketch. I'm going to do it over here. So looks like I have a hole at, and we're going to talk about how Miss Smith got that. So at 5/6, I'm just going to sketch, draw a little round hole right there. And actually, I'm going to make that orange so I can see it better. There we go. There's my hole. And it is 3 and 5/6. It's a hole. How did Miss Smith get the hole? Well, let's go ahead and do our sketch here. Looks like we had, let's go back to the graph here because I forgot what it looks like. Up and down. And my graph stopped at this hole. This is a removable continuity. You just graphed a removable discontinuity. So how did I get my hole? So if you look, after I canceled, what is left over? So my hole, after I canceled, I have f of x equals x plus 2 over x plus 3. Now, typically when we have vertical asymptotes, we set whatever's left in the bottom equals 0. But this portion right here, the portion that canceled, I'm going to say x minus 3 equals 0. So x equals 3. And I'm going to stick it into what's left. So 3 plus 2 over 3 plus 3 equals 5/6. So I have a hole. It's just placed that the graph doesn't touch at 3, 5/6. All right, x and y intercepts. Where does it cross the x-axis? And it looks like it crosses it at 2, maybe. Let make sure that's correct. Oh, nope, crosses at -2, and it crosses the y-axis at 0.667. Okay, so crosses at -2, 0. So I actually should have come over a little bit, should have sketched over a little bit. Okay, and 0, 0.667. Vertical asymptotes, x equals -3. In behavior, as x goes to -infinity, my y values go to that horizontal asymptote. Similarly, on the other side, as x goes to positive infinity, f of x goes to that horizontal asymptote. So I'm going to put as and as. So some interesting things going on there. So this next one, I actually will be using a Desmos to graph this. So just factoring out x minus 1, I'm at x minus 1 times x plus 3 is my factors. Things that cancel, my holes, right? Hole, I'm going to have a hole at x minus 1 equals 0 or at x equals 1. So I'm going to figure out what that is after I get the remainder of what's left. But for now, horizontal asymptotes are going to be right there. Denominator is bigger, so it's just y equals 0. Vertical asymptote. Vertical asymptote, I'm going to get it from x plus 3. It's what's left in the bottom. So x plus 3 equals 0. That means x equals -3. All right, so now let's address the hole here. So what is left in this function? I have 1, 1 over x plus 3. So I'm just going to plug in that 1, and I get 1 over 1 plus 3 equals 1 over 4. So my whole is located at 1 comma 1 over 4. So I'm going to go right 1 up a quarter, and I'm going to create that whole. And everything else is going to come around. Actually, I don't need to go to Desmos to graph this. I can do it here. So horizontal asymptote at 0, y equals 0. So HA, y equals 0. Okay. Whole, already graphed it. It's at 1 comma 1 over 4. Vertical asymptote at x equals negative 3. And this graph, don't know what it looks like, so I'm going to go get a quick view of it and sketch it. So x minus 1 over x squared plus 2x minus 3. And just want to make sure I wrote that correctly. I don't think I did. Plus 2x minus 3. Trying to figure out why I got the whole wrong. Let's see here. Let's see if I did that right. I have, let's change that to, should be x minus 1 over x plus 3 and let's see what's going on with my math here. It's embarrassing. I had a professor that had this happen, and he was never really embarrassed about things like this. Let's see. Let's try negative 1. Let's try that. Negative 1.5. There we go. Had it backwards. Had it totally backwards. There's my whole. Making things up, that's what Miss Smith is doing. Had it backwards. You don't have to change the sign. Thinking too much about these. So it's whatever this number is right here. So it's actually at negative 1.25, and the sketch looks like this. Oh, maybe erase that. Be messy. There we go. There we go. There we go. That looks better. Somewhat better. I should have worked to fix this up. Not being a good example here, but I wanted to get through this. All right. So they gave us everything in this one. So I'm going to let you have at it. You should have no holes. You should only have vertical asymptotes, horizontal asymptotes. And your leading x term here is going to be the same because you have an x and x, x and x. So if you were going to do that, you would say x times x over x times x for the horizontal asymptote. And it's just x squared over x squared, or just 1. So horizontal asymptote here is just y equals 1. And these other things should follow. X equals negative 2 is your vertical asymptote, and x equals 3. And you should graph the function. For the next one, the graph is on the following page. If I factor this, I get x plus 1 times x plus 3 over x minus 1. Nothing cancels. Nothing cancels there. So my horizontal asymptote looking at the leading x terms, there isn't one. So no horizontal asymptote. Vertical asymptotes, we got x equals 1. No holes. And you should be able to find those critical values on the next page. And lastly, just make sure you do the homework today. Have a good day, guys.